Jupiter, the colossal gas giant, reigns supreme as the largest planet in our solar system. Nestled comfortably in the fifth spot from the Sun, Jupiter is a behemoth, dwarfing all the other planets in both size and mass. It's mostly composed of hydrogen and helium, similar to the Sun, but with traces of other elements, giving it its unique characteristics. On its surface, or rather on the upper layer of its dense atmosphere, we see the Great Red Spot, a tempest that has been swirling for centuries, larger than the Earth itself. This gas giant is a spectacle of nature, a testament to the diversity and grandeur of the cosmos. Its massive presence, its swirling storms, and its iconic bands of clouds all contribute to the enigma that is Jupiter. But what if this gargantuan gas giant was not a gas giant at all? Consider a reality where Jupiter, the behemoth we know, was a rocky planet instead. This idea might seem far-fetched, but let's delve into this hypothetical scenario. In the early stages of our solar system, around 4.5 billion years ago, Jupiter began to form in the outer regions. As a gas giant, it's primarily composed of hydrogen and helium, with traces of methane, water, ammonia, and other compounds. But what if the circumstances were different? Suppose the building blocks of Jupiter were more abundant in rock, ice, and metal rather than gas. The planet would have started to form around a solid core, slowly accumulating these materials from the protoplanetary disk surrounding the young Sun. This rocky Jupiter would have been a gravitational powerhouse, its strong pull attracting a hefty amount of solid matter from its vicinity. With time, the planet would have continued to grow, its rocky and icy composition becoming denser and more massive. The process would have been slow, taking millions of years. The end result, however, would be a Jupiter unlike the one we know today. Instead of a swirling, gaseous giant, we'd have a colossal rocky planet, its surface possibly punctuated with towering mountains, deep canyons, and vast plains. In this scenario, the Jovian atmosphere might still exist, but it would be vastly different from the one we're familiar with. Instead of being dominated by hydrogen and helium, it could contain more complex molecules, perhaps even oxygen or nitrogen, depending on the chemical reactions taking place on the rocky surface below. This alternate universe presents us with a radically different Jupiter, not a gas giant but a rocky behemoth, its surface a testament to the diverse materials it attracted during its formation. We're left to wonder, what would this rocky Jupiter look like? Could it be habitable? And what impact would such a planet have on the rest of our solar system? As we continue to explore, we'll dive deeper into these intriguing questions. Jupiter, as a rocky planet, would be a spectacle unlike anything we've seen before. The surface of this reimagined Jupiter would be a breathtaking vista of towering mountains, expansive valleys, and sweeping plains, a testament to the raw, untamed power of nature. Where gaseous storms once raged, there would now be solid ground underfoot. The gas giant's transformation into a rocky planet would have entailed the attraction and accretion of rock, ice, and metal, creating a terrain that's as diverse as it is dramatic. One could envision ranges of mountains that dwarf even the mightiest peaks on Earth, their slopes etched with the history of this planet's violent birth. Valleys would cut deep into the surface, carved by forces beyond our comprehension, while vast plains would extend as far as the eye could see, their barren beauty a stark contrast to the swirling clouds and storms we associate with Jupiter today. Yet the surface isn't the only fascinating aspect of this hypothetical rocky Jupiter. Beneath the surface, a metallic core similar to Earth's might exist, potentially generating a magnetic field. This magnetic field would not only protect the planet from solar radiation, but also create a spectacle of its own in the form of auroras, painting the skies above this rocky juggernaut with colors unseen on any other planet. The magnetic field could also have profound implications for the planet's geology. It could drive tectonic activity, giving rise to earthquakes and possibly even volcanic eruptions. The resulting landscape would be a dynamic, ever-changing canvas, reflecting the planet's internal turmoil on its rocky surface. This is not the Jupiter we know, but it's a Jupiter that could have been, had the cosmos taken a different turn. As we delve into this hypothetical realm, we're led to question not just what we know about Jupiter, but also our understanding of planetary formation and the defining traits of our solar system. The prospects of a rocky Jupiter are as fascinating as they are terrifying. It's a world that challenges our preconceptions and invites us to explore the infinite possibilities of the universe. Could a rocky Jupiter support life as we know it? This question propels us into a world of fascinating speculation. The habitability of a planet hinges on a few key factors: the right temperature, a stable atmosphere, and the presence of water. Let's start with temperature. It's crucial for maintaining liquid water, a key ingredient for life. Jupiter's distance from the Sun places it in the outer realm of our solar system. If Jupiter were a rocky planet, it could potentially fall within the habitable zone, also known as the Goldilocks zone, where conditions are just right. Not too hot, not too cold, but just right for liquid water to exist. Next, let's consider the atmosphere. A rocky Jupiter would need an atmosphere to maintain a stable surface temperature and protect potential life from harmful solar radiation. Given Jupiter's strong gravitational pull, it's plausible that a rocky Jupiter could retain a thick protective atmosphere. Now, on to water. Water is the elixir of life, an essential ingredient in the recipe for biological activity. If we consider that Jupiter's current icy moons, such as Europa and Ganymede, are believed to harbor vast oceans beneath their icy surfaces, it's tempting to think that a rocky Jupiter might also have the capacity to hold substantial amounts of water. But what about the availability of nutrients essential for life? A rocky Jupiter would likely be composed of a diverse range of minerals, providing a smorgasbord of elements necessary for life to thrive. Of course, this is all conjecture. The reality of a rocky Jupiter supporting life would depend on a complex interplay of factors, including the planet's geologic activity, the composition of its atmosphere, and the presence of a magnetic field. But the tantalizing possibility remains. In an alternate universe, a rocky Jupiter might not just be a giant world of gas and storms, but a cradle for life. The possibility of life on Jupiter, once a distant dream, could be a reality in this alternate universe. Jupiter's transformation into a rocky planet would undeniably have profound effects on our solar system. Firstly, let's delve into the gravitational changes. As the heaviest planet in our solar system, Jupiter's immense gravitational pull plays a significant role in maintaining the balance of our cosmic neighborhood. If Jupiter were to transform into a rocky planet, it would likely lose a substantial portion of its mass. This would inevitably lead to a decrease in its gravitational pull, potentially destabilizing the orbits of other planets and even the asteroid belt. This could result in a celestial game of billiards, with planets and asteroids colliding or being flung out into the depths of space. Now, let's consider the potential for increased asteroid and comet impacts on Earth. Currently, Jupiter acts as a cosmic vacuum cleaner, its strong gravitational pull attracting and capturing most of the space debris that enters our solar system. This protective role has shielded Earth from numerous potential impacts, but with a rocky Jupiter, this protective shield would be significantly weakened. The number of asteroids and comets reaching the inner solar system could increase dramatically, raising the risk of impacts on Earth. Moreover, Jupiter's transformation could also impact the Sun's activity. Any drastic change in Jupiter's mass could potentially affect the Sun's motion, leading to changes in solar activity. This could have far-reaching effects on Earth's climate and even our technology, as increased solar activity can disrupt satellite communications and power grids. Lastly, a rocky Jupiter could also influence the potential for life elsewhere in the solar system. For instance, Jupiter's moons, which are considered potential habitats for life, would experience drastic changes in their own orbits and climates, altering their potential habitability. In essence, the transformation of Jupiter from a gas giant to a rocky planet would not just be an isolated event. It would have ripple effects throughout our solar system, affecting everything from the orbits of other planets to the possibility of life beyond Earth. A rocky Jupiter could rewrite the cosmic order of our solar system. The possibility of a rocky Jupiter opens the door to endless speculation. We've journeyed through the intriguing concept of Jupiter, not as a gas giant but as a rocky planet. We've considered its formation, the age-old process that could have drawn in rock, ice, and metal, forming a solid surface rather than a swirling mass of gas. We've pondered the characteristics of this alternate Jupiter's surface, envisioning towering mountain ranges, vast canyons, and perhaps even bodies of liquid. We've speculated on its potential habitability, raising questions about the possibility of life on this transformed Jupiter. We've also contemplated the ripple effects such a transformation would have on our solar system, the change in gravitational forces, the alteration in the asteroid belt, and the potential for new, unforeseen celestial dynamics. While we may never see a rocky Jupiter in our lifetime, it's a tantalizing thought that challenges our understanding of the universe we live in.